We are back again. I just want us to do some strategies on Euclidean geometry. Some may know this and some may not. And for those who do not, DRCPT, some say it's Dr. Cape Town for them to remember this easily. So what is Dr. Cape Town? What does each letter here stands for? Like I said here, the D stands for diameter. If they tell you about a diameter, remember this theorem here, which states that the angle a diameter subtends is equals to 90 degrees, or the angle subtended by a diameter is equals to 90 degrees. If this is a diameter, then this angle here that this diameter subtends is always 90 degrees. So if they tell you about a diameter, just remember this theorem here, that the angle subtended by diameter is 90 degrees. And we have R here. R stands for radius. Remember that a radius is a type of chord from the center of the circle to any point on the circumference. So we call that a radius. If they tell you anything about a radius, remember this theorem here, that equal radii subtends equal angles. If this is a radius and this is a radius, then these angles here are equal. Remember the isosceles triangle properties that we talked about in the previous video. And if this length here are equal, then their adjacent angles are also equal because they are angles opposite to equal sides. Yeah, when they tell you about radius, if they say AO or OB is a radius, remember this theorem here. Let's move on to DRCPT. We are on C now. What does C stands for? It stands for a cyclic quad. This is what we have to remember about a cyclic quad. If they say prove that this thing here is a cyclic quad, you have to prove that these opposite angles here, this opposite interior angles here are supplementary. That means they add up to 180 degrees. So angle A plus angle C, they must add up to 180 degrees. And angle B plus angle D, they must add up to 180 degrees. You only have to prove one of this. You don't have to prove both of them. So if you prove this plus this is 180 degrees, and also this plus this is also 180 degrees, then this thing here is a cyclic quad, because the opposite interior angles are supplementary. Or you can do this here. When they say something is a cyclic quad, that means the exterior angle, this exterior angle, is equals to the opposite interior angle, like this here. This angle, this whole angle here, is equals to this whole angle here. This is what we say, when we say it's a exterior angle of a cyclic quad. So exterior angle of a cyclic quad is equals to the opposite interior angle. But what if the exterior angle was here? Then this angle here would have been equal to this angle over here. If you can prove that this angle is equal to this angle, then this is a cyclic quad. Or if you can prove that this angle here is equal to this angle, then this is a cyclic quad. Look out for this here. And the last way to prove that something's a cyclic quad, it's if when you have a bow tie shape there, like this here. If you can prove that this is equal to this, then this here is a cyclic quad. Or if you can prove that this is equal to this, then obviously this is a cyclic quad. Or if you can prove that this is equal to this, then this is a cyclic quad. Or if you can prove that this is equal to this, then this is a cyclic quad, like I wrote down here. And yeah, proving a cyclic quad is a lot of challenge for many students, but if you know these properties here, you can pause the video, write them down, and yeah, unpause the video to continue. Yeah, let's continue, but just remember these properties here. You only have to prove one here. I forgot to mention, you only have to prove one of this here. Don't prove all of them, only prove one. And here you only prove one, you don't prove both of them. And here you only prove one, you don't prove both of them. And yeah, let's continue. We are on P now. What is P? Parallel lines. We talked about parallel lines. When you see parallel lines, think of fun. F stands for corresponding angles. U stands for co-interior angles. N stands for alternate angles. So let's look at parallel lines. Where did I write that? Let's say you have this type of shape there. Let me see. Great. Let's say you have this kind of shape here. They tell you that these lines here are parallel. Then what can you deduce about this? We can clearly see that this angle here will equals to this angle here. Why? Because they are alternate. This angle over here is equals to this angle over here. And also this angle here is equals to this angle here because they are alternate. Yeah, we talked about parallel lines. You have to look out for the vertically opposite angles on a straight line, and yeah, all those things there that I mentioned in the first video. And let's move on to the last one, which is we are on T now, DRCPT. When you see T, remember tangents. We have two theorems involving tangents. We have this here. Yeah. And this here. We know that if this here is a tangent, this line here is a tangent, ABC is a tangent, then we know that this angle here equals to this angle here. Why? And another strategy to find this here is when you have this tangent here, you put your two fingers on the ends of the chord. This is the one end of a chord, this is another end of a chord. You make your two fingers meet. Where do they meet? Of course they meet here. Then this angle here is equals to this angle here. And subsequently we can do this here. We can put our finger here, put our finger here, make them meet. Where do they meet? They meet here. So this angle also is equals to this angle here. Yeah, just to know this about the Tancourt theorem. Another theorem which we proved is this here. And what we have to remember about this theorem is that this here, what do we call them, the tangent, or the tangent from the common point, just know that they are equal in length. They are equal in length. That's what we have to remember about this theorem here, that tangent from the same point are equal in length. Sometimes they might give you the angle of here and ask you to calculate the angle of here, or they give you the angle of here and ask you to calculate the angle of here. So we will do all of that in the next upcoming videos. And yeah, I think we are done for now, because I talked about lots of things that will be very, very helpful when we prove this Euclidean geometry stuffs. So I will see you in my next upcoming videos. For now, bye.